Hello! In this video I will show you a little bit about what I've been working on lately. I have made a clustering algorithm that works in an interactive way, so we can first sort events in FCS files in such a way that similar events are next to each other. And when we've done that, we can, from a visualization of that, from a heat map, we can cut up or split the events into clusters. And we do that, or I can do that in an interactive way. And here is a notebook where I have prepared to load in some data. And the data I'm loading in is downloaded from cytof. It's an experiment of Spitz et al. It has been published in Cell, so I can show you the paper, I guess. It's here, and it's a typical, cytof biology paper where they do clustering. They have a method of their liking, of their own, that they call scaffolds, I think. And then they come with some conclusions that these populations and these populations are affected by therapy or by strata of patients or mice or whatever they're looking at. I don't understand much of that, but I've been browsing through the paper and looking at all of these statements about markers, and I've been trying to see what can I look for. And I decided by looking through this, I don't know when it will appear, that there was one marker that was particularly mentioned. It was the CD86. And they said that T cells were the ones that were driving the differences. So I'm going to look for T cells and see if I can find subpopulations that are positive for CD86 and see, what happens with those. So what is the data we have here? I can go back to the experiment. We have a number of FCS files. I think it's 26, with roughly 11 million events in them. And so the titles kind of suggest that there are different conditions in each of the samples. But they are in groups, so there's a group of untreated, there's a group of CD1 antibodies, B6 antibodies, and anti-PD1. What it means, I don't know, and this is longitudinal. There are day 3 and day 8. So maybe we'll distinguish between the days, maybe not. I want to just try to dig in and see what happens on a first attempt. And before I get started, so I start by telling Jupyter that I want to show interactive data, and then I import my tools. And the files that we have here, if we take a look at it, I don't know if this is here or here. No, not here. So if I knew where to look, this thing would tell me that there's an information. Oh, it tells me that my session has expired. Please forgive me. I don't think this was what I wanted to know. So what I want to know is that they say that there are warnings. There are some problems with the files. Now I'm somewhere else. I don't know what happened to cytof. So for that reason, I'm suppressing warnings because there are errors in the FCS files. So now here I have downloaded all the files to some position in my computer, and there are different keys in FCS files that can hold the names, either the PNN or the PNS. Here it's the PNS. Usually I use the PNN, so I specify that and say now we construct one of my gating or clustering objects. I try to read what are the channels in the files, there are here, there's a list of channels, and then I read in a sample of 10,000 events from each of these 26 files. So I'm going to cluster only a subsample of all of the files. In the first approach, this clustering will be so manually guided or user guided, and when I've done that, I have another notebook that I will run where I'm using the clusters that I decide here to make clusters expanded from those in every FCS file. So all events are going to be clustered eventually. So I guess I should start making my subsample. It takes half a minute or so because reading in FCS files is not the most efficient thing you can do. So in the next cell, I decide which of all the markers in the file do I want to use for clustering. And that's kind of hard to decide. So what I did, I went into the supplementary of the paper and saw that they give a list here. So I've been, semi-manually plucking out all of these markers and typing them into my notebook. So when you have your own files and you know about it yourself, you can, I picked out the ones I want. And then I say these are the ones I use for clustering, and I start my clustering object. So this is also going to take a little while, but I think I will just let you wait while it's processing. So the method is kind of what we've been talking about in the cytof meetings at the hospital. And so it's a variation of single linkage clustering that can cope with pretty large amounts of data. And when that is, so what is happening now is that I have sorted the events so that similar events are next to each other. So now I'm ready to make a user-guided clustering. So I tell my object to show what it has, and it has 3 buttons here: Abundance tab, Heat map tab, and UMap tab. So I'm going to concentrate on the Heat map tab for now. So that will give me the heat map that I announced. So it's a little bit too big to fit on the screen, so I have to roll up and down. But I could, if I would want to, so I could make it smaller so that it fits on the screen. So now there's a cluster ID, so cluster ID is 0. There's only one cluster, cluster 0. Then there's a minimum cardinality. So minimum cardinality, so that's what is the least amount of events I want to have in a cluster when I split this cluster up into 2 pieces. And I think I will say 10,000. And then I say split this cluster. It is taking a little while to work on this. And now I see I have 2 clusters. What can I say about them? Cluster 1 seems to be CD3 positive. Cluster 2 seems to be not CD3 positive. So I have gated out the T cells. And I said from the outset that it's the T cells that interest me. So now I can go and say, show me only the cluster that had the identity 1 here. So now I've zoomed into the T cells, and I said it was CD86 that was interesting me. CD86 it's small pieces, so we need to drill a little bit in order to drill into them. So what is a good size? So 10,000 will be too big to accommodate this, but maybe we'll do some 5,000 just to see what happens to get started. Okay, so that made one cluster with the CD8 positive and one cluster with the CD4, well, mostly CD4 positive. There are some that are CD3 positive, but CD4 negative. I think we'll go on. And now I have to decide, do I want to split cluster 3 or cluster 4 up into smaller pieces? So I already have a suggestion for cluster 4. I'm going to stick with that, and to say 5,000 is the smallest possible size, I think that's good enough. Okay, now I got a new cluster. It's kind of hard to say what distinguishes that from the rest. So I can say, well, it didn't look very understandable. Let me undo. Let me unsplit this cluster. So now I have cluster 3 and 7. 7 is what was 4 before. But yeah, I need to keep counting. So maybe I say 1,000 is a more reasonable number of cells. 8, yeah, cluster 8, I understand. Here I have the ones that are both CD4 and CD8 negative. That's good. And I see that there's something crazy going on here, something that is positive for all markers, but it's rather small. I also see there's something here that is positive for TER119. So let's see what happens if we just go on. The next one, what is the next one? The next one is Tibet. Okay. I saw this mentioned Tibet in the paper, so now we have a cluster with Tibet. What about the CD86? It seems to be, I cannot say. Is it in this cluster? Let's go and look. So now we can just look at the clusters 8 and what was the other number? Oh, 8 and 10. CD86. Oh yeah, we have the CD86 in cluster 10 here. So cluster 10 has caught my attention. I want to drill further into that because I want a single cluster with CD86 in it. So how big can it be? Well, 1,000 is still a good number, I guess. So we say 1,000 and split cluster 10. Yeah. Now cluster 13 seems to be mostly CD86, but there are some empty spaces, so we want to make it smaller. So do I want to say 1,000? I think I want to say 800. And it's cluster 13 I want to split. Does anything happen? Nothing happened. So this might be because it rejects to make such a big cluster. So let's try again. It might also be because I have a bug in my code. So let's make a new heat map tab and see if... No, it's... It seems... Oh yeah. Maybe... So I wanted to split up cluster 13, but I think what happened is that I got something to the right of cluster 13. So that's a small bug I need to fix. So what is to the right of cluster 13? We can take 11. So let's just see what happens here. No. So let's see. I want to split cluster 13. Oh, here it was. I don't know. This is not very satisfactory. So now I got the CD86 in 2 different clusters, but maybe it's because of these other things. Lys6C. Yeah, it might be. So I think I want to unsplit if I can, if I may. And then I want to make this even smaller. And let's see if it's splitting. Yeah, it works. It seems to work. Yeah, so now I got 1 in cluster 17, that's good. I go on, split up cluster 18, 19, 20. Yeah, it seems that cluster 20 still, no, cluster 19 still needs to be split. So let's try to do 19. Split. Yeah, now I'm good. Now I have the CD86 negative ones in cluster 22. And yeah, cluster 20 is a little mixed, but I think I'll go with this. So now I've drilled in a little bit. What happens if I go and look at my original heat map? I see it's a little bit over here that I've drilled in. And now I would like to see what is a U-map, first of the whole thing, and then maybe a U-map of the T cells. So getting a U-map takes a little while, so I'll let you not have to look at this, so I'll be back in a second. So here is the U-map of my clustering. I see that it's only a portion of the events that I have been drilling down to and clustering. And now I want to make a U-map of only the T cells. So that's the clusters between 3 and 11. So then I ask for a U-map of that too. And I let you, not wait for this. So here is the U-map of the clusters I made in the T cells. So let's see. So I think the brown ones, what are they? I don't know. Let's see if we can see now heat maps. Lean into our heat maps. Number 11, 11, 11, that's the CD4 positive. So the yellow one is the CD8 positive T cells. And what we've been drilling into is something that is kind of in transition between the two. I think I'm going to be satisfied with the clustering I did now. So the idea is to check now if the clusters we have distinguish the different groups that are specified by the file names. So what I'm doing now is I'm saving the clusters I produced here. So I'm saving, so for technical reasons, I'm saving FCS files, and I have to read in the non-transformed FCS files because I like to work with those or have those at the first thing, not to save transformed data. So now I loaded in the samples that I've been working with on non-transformed, and now I save those again. So this is a small file. That goes quickly. So I think I will end this video here, and then I will make a new video where I will make a heat map showing differences between the different groups. So this is from a different run. Now we have different clusters, so we'll see how that will look in the next video.